maximize my profits, assuming I can sell them all. Does that give you some idea of what we're moving towards, if not how to do it yet? Okay, for the homework tonight, what it's going to be is looking at these and either just graphing them and finding minimum and maximum values of an objective function, or there's some other like matching, see if you can recognize a set of constraints, which one is which really is basically like, can you recognize what you did on the last problem on the last test? For some of you, that may not be yes yet, and I understand that. On Monday.
Wait.
Yes, now Nini.
If you don't understand this today, then you think you're going to do our homework.
Did you understand the process that I just went through?
In a way.
Okay, in a way. All you're going to be doing is graphing these. No. You'll be graphing these, sets of these. You'll be finding where they intersect. That was all on the last test. So if you didn't understand that, Nini, the time to talk to me is before the last test. Okay? You know how to graph these. You know how to find intersection points. Once you get a region where all of the constraints are true, that region will have corners. Those corners will have coordinates. You plug them into the equation you're given.
Oh, I got it.
Really? A little surprised that worked and all.
Not completely, but I got the like system, like I know what to do.
For today, it's like you're going through it a little bit by rote. I won't lie.
And that's my notes, so.
Not yet. I'm going to show you one other thing first. Yes, Amanda.
Okay. So when you graph them, when you have to make a table, right?
You're graphing the constraints. A lot of them will be easiest to graph by table, but I'm not telling you specifically how to do it. If you want to change this to slope-intercept form, go to town. If you want to plug in random points on a table, have fun.
Okay.
I think this is much easier for this type.
Yes, okay. So then you get the points from there, right?
Yep, find all the intersection points just of the true region. Notice I left out this area and this area because they weren't true. Not every statement was true here and here. You're only looking at the area where all four of these statements are true.
That's not like 4 would be probably.
Okay, so
There's literally like 5. It's like 10 to 20 even.
0,
So
0.
it's not much.
Good.
Now the regions will look different.
6.5 and 0.
Yeah.
And that's it?
Well, then you have to plug those into what you'll be given, which will be called an objective function, and find these values.
Oh, and the point of intersection.
Yeah, and the point of intersection,
Okay.
3, 7. Okay? This is a process you guys should be ready for. I'm going to show you real quick a visual picture, a computer-generated picture of this that I hope will help a little. If it doesn't help with the homework tonight, it should help with... No. This is just...
Are we done with that then?
You're not done paying attention.
Well, no, I've just been writing down.
I like
Correct.
your blue light.
Isn't it fantastic? It's my favorite channel. I watch it all the time.
Were you drinking?
Okay, now, hey, guys, we're still recording. Okay, now, here's a graph where I've put in, how many constraints did I put in? I put in 5 constraints. No, put in 3 constraints, that's all.
It's similar to what we just did.
It's very similar to what we just did. I put in 3 constraints, and this darkest region in the middle is where they're all true. Okay, there are some ugly colors up there. Now, do you guys see this darker line that goes through them all?
Yes.
Okay, this region would represent all the possibilities. I used a manufacturing example, and that's the most common use for this. This darkest region here would represent my region of possibilities. Whenever you're making something, there are limits. You can't make a negative amount of them, and you can't just turn on your factory and make 1,000,000 of everything you want to make. If you're making tables and chairs, you can't just make 1,000,000 of each. There's a reason why, for whatever reason, I can apparently only make 8 chairs and 4 tables at a time, in whatever time period we're talking about.
6. Or 6 and 6.
Well, if I make, the way this would look if this were tables and chairs, if I make 0 chairs, apparently I only have enough for 4 tables. If I make 0 tables, I would only have enough for 8 chairs.
So what about that line that intersects?
Oh, along these, well, this dark line here doesn't represent a constraint. This dark line would represent maybe my profit from making tables and chairs. 1 sec, Sarah. And this thing can have multiple values. Like, for example, I can choose where this dark line goes through. If this dark line represents my profit, I can choose how much profit to make. You see my profit line going through the origin? This represents how much money I would make for making 0 tables and 0 chairs. Okay? if I take my profit line and I move it so that it goes through the region, okay, then any point in this region on here, I can pick any point in here, the point 2, 1, okay, and this profit line will tell me how much money I will make if I decide to make 2 tables and 1 chair, okay. The maximum profit, the maximum value you can possibly get on this line will always be where this line intersects a corner. The maximums and minimum values for this line will always be where it hits a corner. This is a minimum value here. I can make no money. Correct? Mm-hmm. My maximum is either going to be this corner or where the line hits that corner.
What are you doing?
I'm moving my profit line up and down. Remember I said that this objective function over here, c equals 3x plus 2y?
Did you make that up?
Yeah. Remember I said this represents a family of parallel lines. If I, hang on a second. Hang on, Amanda. Hang on. We'll see where these come from next week. But just take a look at the math here, Amanda. Lift your head and look. Lift your head and look. Okay. If I graph a line in standard form and I change this number, it creates a new line parallel to the original. This represents any value I put in for C. If I put in 2 different values for C, I've created 2 parallel lines. And where these lines hit these corners.
The equation,
Pardon?
equation is total. That thing, C equals whatever,
Yeah.
is totally different than that thing.
Has nothing to do with the graph. You graph using
No,
the constraints. Yeah, this is where you get your graph.
Where did you get that?
Well, I made it up. The problem, it'll be given to you each time.
Oh, I was like, oh, do I make it?
No, you don't make that up. You don't use these to get this, okay? You're given these separately. Okay? Now remember, this is the equation we plug the values in. But our lowest and highest values will always be where the line hits a corner. That's the important concept behind it.
You have an email.
I do. Fantastic. Thank you.
Julia was born in 92.
You know, that's actually important information for me. I'm going to turn that off now. Okay. Questions, comments, complaints, compliments?
No.
Oh,
Yeah, I don't know.